the direction in which it is opening. Okay. You also will have to be able to identify the vertex, the focus, the directrix, and the endpoints of the lattice rectum. And then, of course, sketch the graph. So in any type of these problems, these are the things that you're going to have to be able to do and have to be able to figure out how to do based on the equation, given the equation. So I'm going to start with this equation. So the first thing you look at is you must identify which variable is being squared. So our x is being squared. So the x variable is being squared. So that tells me that I will be opening either up or down. Because all the other equations, all the parabolas we've done up to now, the x's were squares, y equals x squared something. And so our graph's either opened up or down. So the same thing happens this way. So if the x is squared, your graph will be opening up and down. If the y is squared, you'll be opening either left or right. That's the new one. So we'll have those new sideways. All right. So I figured out that I am opening up or down. To figure out which of those is optional, which one it is, you have to find your C value. To find your C value, once it's in this basic form, you take whatever you're multiplying the y by, and that's equal to 4C. So I know that 4C must equal 8. So therefore, C has to be what value? 2. Solve that little equation, I get C is 2. All right, so if our x is squared, let me move that up a little bit. Okay, so if x is squared and C is greater than 0, it will open up. Direction of opening would be up. Okay. If x is squared and C is less than 0, a negative number, our direction of opening will be down. That's how we're going to figure out our direction of opening. So in this case, are we opening upwards or downwards? Up. That's our direction of opening. Okay. Trying to think, does your book refer to a standard form or general form? Standard form. Okay, your book refers to as the standard form. The standard form of any parabola would either be is x minus h squared equals 4 times c, y minus k, or if the y term is squared, it'd be y minus k squared equals 4c x minus h. Notice the h's always stay with the x, so k always stays with the y. Okay, so those are our two basic standard forms that you're going to get. And with h and k is our vertex. So h and k is how we figure out our vertex. So vertex is always going to be h comma k. So in this form, what's my h and what's my k? 0, 0. So my vertex for this problem is 0, 0. And that's going to be my h and my k. Now this is where I'm going to go away from the formulas and I'm going to start talking about the visual approach. So now I'm going to show you how I do it visually. Away from the formulas. Everybody have these two formulas down so I can erase them? And so what I do to help me kind of figure this out is I'm going to kind of do a little quick like sketch that's going to go on here. Okay, so I've already figured out that my vertex is 0, 0. And I know my graph is going to be opening in the upwards direction. So I know it's going to be going up something like this. Okay, I'll figure out exactly how it's going to go in a moment. But I know it's going to go in that area. And I also know the focus is always inside the parabola. That's something to remember. Focus is always inside. So since I know my focus is inside, and I know the distance from my vertex to my focus is always C, and that you do have to memorize. The distance from your vertex to your focus is always C. So the only way I'm going to get C distance from my vertex and make it inside the parabola is if I go up C units. And so that's what I'm going to do. If C is 2, I go up 2, and that gives me my focus. So I'm just going straight up from my vertex. So my focus is either always straight up, straight down, straight left, or straight right, depending on the direction of opening. So if my direction of opening is up, my vertex is straight, my focus is straight up from my vertex. If the direction of opening is down, my vertex is straight down from my vertex. If it's to the left, it's straight to the left, C units. If it's to the right, it's straight to the right, C units. So that gives me my focus. So just looking at my graph, I see that my X value is still 0 and my Y value is 2. Now, if you like formulas to find this focus here, this would be H, comma, K plus or minus C, depending if it's opening up or down. So that's the formula. So I do the visual, I don't use the formula, but that's the formula if you want to use the formula for that. I'm figuring out your focus. All right, so if the focus is inside the parabola, the directrix is always outside the parabola. And it is the same distance. It is C distance from the vertex. So again, this time I'm going the opposite direction of the opening. So I need to move from my vertex C units, so 2 units, and then draw my directrix. Directrix is this dashed line that goes through here. Because I can get any point on the directrix, goes to the parabola, it would be equal distance from the directrix as to the focus point on any given point that I do there. Okay, so that's my directrix. So directrix is always written as an equation. It's a horizontal line, so horizontal lines are that y equals or x equals. That would be y equals. So this is going to be y equals, in this case, since I went down 2, it's going to be negative 2. Oh, that's hard to read. That's y equals negative 2. So I figured that out by looking at my graph. Now, if you're one that likes looking at the formulas, the formula for this one is y is always equal to k. And then you have to figure out if you're going to add or subtract the C depending on the direction of opening. You always go in the opposite direction. So if I added the C to the focus, I need to subtract for the directrix. I subtracted for the focus, I need to add for the directrix. So those are always opposites on how you figure it out. Because here I added C up and subtracted C down. And that's how you figure that out. Okay, the lattice rectum is this imaginary line we never draw that goes through the focus, okay, parallel to your directrix, through the focus, parallel to your directrix, and the entire length of the lattice rectum is 4 times C. So from the focus, what that means is to figure out how wide I need to draw this for my focus here. this tells me I need to go 2 times C units in this direction and 2 times C units in this direction. And then those are giving me 2 endpoints of my lattice rectum. Those are my endpoints of my lattice rectum. That's something I need to define. So since C is 2, 2 times 2 is 4. So that meant from here, I need to go straight 4. 1, 2, 3, 4. There's one endpoint on my lattice rectum. And you can see that that's 1, 2, 3, 4, comma, 2. So it has the same height as my focus, because I'm opening up or down, but it has 2 times C I've added to my Y value of that focus. Okay. And then the same thing here, it has the same height as my focus, so I know these endpoints are going to have the exact same height, so the Y is going to be the same. It's going to have the same height as my focus. But here, I took my focus and I added 2C, and that gave me 4. Now I'm going to take my focus and subtract 2C. So 1, 2, 3, 4. This gives me my other endpoint at -4, 2. So my other endpoint here is -4. Okay, so now I have everything I need to draw my graph. All you do is connect your 2 endpoints of your lattice rectum with your vertex as a curved parabola shape. There's your sketch. So that's how I would sketch the graph of this. So I figured the direction opening, my vertex, my focus, my directrix, my endpoints, using my focus for that. And then I've now also sketched the graph. So we'll do one more together. Yeah.
What would determine for the directrix be if it's like the sideways? Or is
That's what we're going to do next.
Okay.
So you're just right ahead of me. That's what I'm going to do next on that. So I can see it. Any other questions over this one? Okay, so let's do one more. This time I'm going to do my y is squared. Okay, so now we're going to look at this time. So this time my y is squared. So this seeing the y squared, that tells me it's going to open either one direction or the other direction. What's the 2 directions? Left or right. So I know my direction of opening has to be left or right. So I need to figure out C. So I know 4C is equal to -16. So what does C have to be? -4. Okay, so C is negative and it's opening left or right. So which choice should I choose? What was that? Left. Because it's negative, so it's opening in that negative direction. So this is opening to the left. Because the y is squared and the C is negative. That's how I made that decision. So I know I'm opening to the left. Okay. So first thing I need to do is figure out where my vertex is. So where would my vertex be? This one's again 0, 0. And I don't have those parentheses adding anything to anything, it's a 0, 0. Okay, so I got my vertex here at 0, 0. I know I'm opening to the left, so I know it's going to be going in this direction. So will my focus be to the left of my vertex or to the right of my vertex? To the left of my vertex. How far to the left of my vertex will it be? 4. I see units. Okay, yeah, and when we're talking about distance, we talk about the absolute value of that. So we're just looking at 4 units. Okay, so I know I need to go to the left of my vertex 4 times, 4 units. 1, 2, 3, 4. Here's where my focus is going to be. So what would be that order pair? Huh? -4, 0. Okay, so vertex, so let's get some formulas down here. So we know our vertex is still HK. Then our focus this time is H plus or minus C, comma K. So this time when it's opening left and right, I changed my X value, not my Y value. That was the difference. And again, I decide to add or subtract C based on if it's opening to the left or to the right. You make that decision. And so our directrix needs to go in the opposite direction C units. So 1, 2, 3, 4, and I draw my directrix. Okay. And you can always think the directrix will always be perpendicular to your axis of symmetry. So I knew it had to be up and down. So this time when you do the directrix, is it going to be X equals a number or Y equals a number? X equals number. In this case, X equals 4. Okay. So our formula here is going to be X is equal to our K plus or minus C, depending on which direction of opening that we want. So our vertex plus or minus that. Okay. Next thing is I just randomly drew this to help me fix this. So I need to fix those random widths to the actual appropriate width for this graph. Figure out how wide my parabola is. And so to fix this width, next thing I need to do is figure out my lattice rectum endpoints. And remember, the lattice rectum is always going to be parallel to your directrix. So it's going to be running up and down. And I need to go from my focus up how many units? 8. 2 times C. So I need to go 8 units up from that focus. 1, 2, 3, 4, 5, 6, 7, 8. So what would be the order pair for that point? -4, 8. So that's going to give me one input endpoint at -4, 8. And then where would the other one be? -4, -8. 1, 2, 3, 4, 5, 6, 7, 8. And so to figure that out, notice this time my X values of my focus remain the same. The Y values, I take my focus Y value and I plus or minus 2C. So that's what I'm adding there is 2C. So in formula speak, we have our focus, which is H plus or minus C. And then our K, and then adding either plus or minus 2C. Oh, you can't see that C. Try that again. K plus or minus 2C. So those would be the formulas you gotta get. Okay, so that's our basic. So So our shape of our graph here is a little wide opening. Whoops, why is it doing that? It's a pretty wide parabola opening up to the left. And that's my graph. Okay, questions over those? Okay, so go to our Canvas. You have a new quiz called Conics Parabola. Conics Parabola, and only do, I think it's first 4 questions. Let me check. First 5 questions. Only do questions 1 through 5. So, complete questions 1 through 5 on the Canvas quiz, Conics Parabola. Okay. For our next type that you're going to see is it's not going to have that vertex at 0, 0. The vertex is going to be slightly different. So we're going to see that more that H and that K showing up. So for our first one here, let's look at x plus 2 squared is equal to negative 20, y minus 3. Okay. So I'm still going to be asked to find all the same parts. So I need to figure out what my C is. I'm going to have to find my vertex, my focus, my directrix, and the endpoints. Lattice. And then I'm going to sketch my graph. We'll be looking at all these pieces again. All right, so first thing, is this a opening up or down, left or right? What's going on? Which direction of opening is this? Okay, I should have added that in there as well. Okay, how did you figure out that it is opening downwards? Negative what? Because a negative 20, so it's negative. So that would either be down or to the left. And how do you figure out which of those two?
X being squared.
The x is being squared. So my x variable is being squared. So I know it had to be up or down. And my c value is negative. So I know it has to be down. So that's how I got it opening downwards. Now, what is c? Negative 5. So you found that by taking 4c is equal to that negative 20 and solving that, and I get c is equal to negative 5. So I got that 5 distance that we're looking at. All right, now looking at this, what would be my vertex? Very good. It is the negative 2 and 3. Because remember that form I put on there at the very beginning was x minus 8 squared equals 4c y minus k. So it's the opposite x and the opposite y in this form. Opposite and opposite. Because both of these are formula has negative in it. And our vertex is hk. So that means it needs to be a negative 2 and the positive 3. So that's going to be my vertex there. All right, so let me start doing my graph a little bit here. Okay, so I need some room. I'm going to be opening downwards, and I'm going to start at -2, 3. So most of mine is going to be on the downward way. A little, I give myself quite enough room. Okay. So I already figured out my vertex is -2, 3. So there's my vertex, -2, 3. Now I know it's opening downwards, so I know I'm going in this general. My endpoint, my indicator is going like this. So it's going open this direction. Okay, so should my focus be below my vertex, above my vertex, to the right of my vertex, to the left? Which one should my focus be? Below. So I need to go directly below my vertex to get my focus. How far down do I need to go? I have to go down the 5, the distance of 5. The -5 tells us we're going down. So 1, 2, 3, 4, 5. There's my focus. So what would be the order pair to that point?
-2,
-2, -2. So my focus is -2, -2. Notice how I found that since I was going down, I took my H, stayed the same, and my K, I subtracted my C. If I'd been opening up, I would add my C. So it's going to be that plus or minus C to get my focus there. I did it visually. So I know that's my focus. Okay. Now I need to figure out my equation of my directrix. So if I went C units down to get my focus, I need to go the opposite direction to get my directrix. So from my vertex, I need to go C units up. So C is 5. 1, 2, 3, 4, 5. Oops. So my directrix 1, 2, 3, 4, 5 goes through here. There's my directrix. So what would be the equation of that directrix? Y is equal to 8. Okay, and equation wise, since I went up, I took my Y is equal to my K, and I added C, but if I had been opening downwards, I might subtract C. So this depends on which order that you're doing now to figure out that equation. Okay, so that's my equation, my directrix. So now I'm looking at the endpoints of the lattice rectum. So this is focusing on my focus. Yes. Okay, so I started at my vertex. I know the distance, the perpendicular distance from my directrix to my vertex is C. Okay, so I know that my vertex here was at the point -2, +3. And so I went straight up from my vertex C units, which is 5. Okay, so I just added 5 to that. And so I added 5 to the 3. And so that gave me 8 that I needed. And since it's an equation of a horizontal line, it's y equals. That gives us the y equals here. All right, so now, this will be purple. Okay, we're going to find the endpoints of our lattice rectum. And so focusing on my focus, and I remember my direction of opening is downwards, I need to go horizontal to my directrix. So my lattice rectum is always horizontal with my directrix. And so what distance do I go in each direction of that focus?
2C.
2C. So in this case, I need to go 2 times 5, which is 10. So I need to take this focus and subtract 10 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what would be that ordered pair?
-12, -2.
-12, -2. Write that here. And let's add in, it was missing 2, it marks that it do. Okay. That's that -12, -2. And then I need to go adding from the same height here. I'm gonna go straight across 10, 2 times my C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What would be that ordered pair? 8, -2. So I have it at -12, -2, and 8, -2. And so I took my focus X value plus or minus 2C. Gave me my X values for my endpoints of the lattice rectum. And then the Y value of my focus is the Y value of my endpoints of my lattice rectum. And so now, using these 3 points, connect that with a smooth parabola shaped curve. And there's your graph. And we're done with this problem. Okay, questions over it? Do the same kind of thing if it opens left or right. So complete the next 3 problems. 5, 6, I think 6, 7, 8. Yeah, 6, 7, and 8 is in this technique. So go ahead and do 6, 7, and 8. Ask me questions if you have any. Hi, picture. Okay. All right, so the last kind of one I want to go over with is sometimes it's going to be written in a form that doesn't look like that we can't easily find our vertex from. It doesn't look like the other one. So you'll often see these parabolas written like something like this. We got x squared minus 4x minus 24y plus 28 equals 0. You'll see it written in this form. And so what you have to do is you have to convert this into that x minus 8 squared equals 4c y minus k, or y minus k squared equals 4c x minus 8 form. So we're going to have to rewrite this so it's in this form, and then we can do what we just did on the last section. So I'm going to talk about in this one how to rewrite this equation so it looks like our standard form here. Now to do this, the first thing you have to do is recognize which variable is being squared. Is the x variable or y variable being squared? So in this case, what variable are we squaring? The x's. So the x's are x squared. So your first step is to write every term with x on the left of the problem, and every term that doesn't include the x moves to the right of the equation. So I'll rewrite this as x squared minus 4x, and I'm going to leave myself a blank here. And then I'm going to move the y term over, and I'm going to move the constant term over. Of course, when I switch over to the equal sign, I have to change operations. So I'm going to be adding the 24y and subtracting the 28. So that's your step 1. Rewrite it so the variable that is being squared, all those variable terms are on the left by itself, and all other terms on the right. Then we're going to do complete the square, as we learned earlier in the year when we were doing the quadratics last time. And so I'm going to have x blank squared plus blank. Now this is going to be slightly modified. Usually we added something and then we subtracted something. But if I'm adding something to the left-hand side of the equation, I can add that same thing to the right-hand side and it still balances my equation. So I'm just going to put my blank slightly at different spots this time for the completing the square. Okay, the bottom blank, does anybody remember what goes there? It would be -2. You take your b term and divide that in 2. So it's always that x term, that b term divided by 2. So -4 divided by 2 gives me a -2. And then I take that answer, that blank, and I square it, and that gives me this blank up here. What's -2 squared? 4. So 4 goes here, 4 goes here. That's how we're going to do the completing the square. Okay. So all of this is now x minus 2 squared equals, we have 24y minus, combining our like terms, that's -28 plus 4. -24. Okay. I'm almost in this 4, but remember, I need to get this y so it has a coefficient of 1 inside the parentheses. So whatever, and it doesn't matter if it divides equally into this or does not, whatever that number is that you're multiplying the y by, you have to factor it out of everything on that right-hand side of the equation. So I got x minus 2 squared is equal to 24 parentheses. And then what do I get left over if I factor out a 24? Y minus 1. And so now it's just like the problems we just did. We can identify our vertex, our focus, our directrix, all that stuff like we've been doing. So these problems just add a little steps ahead at the beginning. So you have to complete the square first, and now it's like those problems you just did. So I'm not going to work through those since we've done those already. Okay, let's try another one where you have to complete the square. Okay. Okay, so what would I do first for this problem? All right, so the y's this term are the squared, so the y terms stay on the left-hand side, and everything else moves to the right-hand side, changing our signs, so it becomes a -12x plus 3. Then I'm going to do my complete the square by filling in my blanks. I'm going to have y what squared? It goes down there at this bottom blank. Okay, very good. It would be -3. So I took that -6 divided by 2, which gives us -3. And -3 squared is 9. So I got to add 9 here. And what I do to the left-hand side, I have to do to the right-hand side. So I add 9 here. So that gives us a -12x plus 12. So I get y minus 3 squared equals -12 parentheses, not plus, x minus 1. So I had to factor out that negative. That has to be a 1. Okay, I want you to try this one. I'll give you a moment to try it. Make sure you got this down. X squared plus 4x plus 8y minus 4 equals 0. Rewrite that into our standard form. Now we can easily identify the vertex for it. Okay, so x is our square term, so I write x squared plus 4x plus my blank is equal to negative 8y plus 4 plus some blank, x blank squared. Okay, what goes in the bottom blank? Positive 2. Positive 4 divided by 2 is positive 2. What goes in this top blank? 2 squared is 4. And then I add 4 here. Okay, and I get negative 8y plus 8. One more step. Take out that negative 8, sorry, gives me y minus 1. Now, sometimes you might get where it doesn't divide equally. I know the examples I did here, that term there, that 8 or whatever term always divided equally. Sometimes it doesn't. That means you're just going to have fractions, and that might happen. Okay, go ahead and finish it up so you can do the rest of the problems.
It always has to go to 1 minus 1 or x minus 1.
It always has to have, it might not have a minus 1 or something like that. It's, the x term always has to have a coefficient of 1 inside the parentheses, and the y term always has to have a coefficient of 1. Yeah. But it could be any fraction, it could be any number there. And sometimes there might not even be a number, it might be 0. You're going to take a picture, and then you're going to do it like you normally do for submitting it, convert it to a PDF, and just upload it here. Yeah, I think you have to save it on your computer or somehow, and then just drag and drop it. But and to upload it. I think some people were emailing it too. Yeah. Slightly different way around.